Welcome back to the classroom. My name is Mr. Wong. In today's lesson, we're going to be looking at Module 5, Inquiry Question 3. This is to look at orbits or objects in uniform in gravitational fields and how they interact. We have a capsule that travels around the International Space Station in a circular path with a radius of about 200 meters. The question says we need to analyze this system to test the following hypothesis. The uniform circular motion of the capsule around the ISS can be accounted for in terms of the gravitational force between the capsule and the ISS. So what exactly are we trying to do? What is being required of us? Well, we need to analyze the hypothesis. So we want to see whether or not it is correct. So is this correct? And what is our justification for whether or not this is correct? Okay. Now, analyze in many ways. You need to explain the cause and effect and also give your decision. In this case here, you can actually see they've given you some important values. They've given you the mass of this particular International Space Station, and we have a secondary mass of our capsule. We also have the velocity as the object is going in a circular radius. So what we can actually say is, if this statement is true, then the force of gravitational attraction between the two objects should be the only thing that contributes to the centripetal motion. So if it's uniform, then Fg should equal to Fc. So we'll do a little calculation to demonstrate whether or not that is correct. And from there, we should be able to tell if this hypothesis is correct or not. Okay? So let's have a go at this problem here. So I'm going to say Fg and Fc are equal, just as a supposed way of measuring. Or actually, in this case, we don't actually know if they're equal or not. So we'll try and do the calculation separately. So we have G m over r squared. And then we have Fc, which is mv squared over r. So little m will be for our capsule, and then big M will be for our space station. So if we put in the numbers, capital G is the gravitational constant. Big M is the mass of our space station. And then we have our capsule. Whoops, forgot that should be squared. Okay, hopefully I don't encroach on the space. And then we have 200 meters squared. Now, just before I go on with the calculation, please make sure everything is in the correct SI units. So mass is in kilograms, distance is in meters, velocity is in meters per second. Just because that can fuddle around with our numbers if we don't have the correct notations. So we have a mass of 1.2 times 10 to the power 4. And then the velocity of 0.233 square over the radius of 200. Okay, so I am going to write down the numbers between the two, and then we'll see if they equal or not. Okay, so Fg is 0. If we count the zeros, well, actually let's write it in scientific notation. So 8.4 042 times 10 to the power of 1, 2, 3, 4, 5, 6, negative 6. Let's find our centripetal force. So that's in newtons, and then this is 3.257 34 newtons. So clearly from our results here, the gravitational force is not equal to the centripetal force. Okay, so from the calculations, Fg is not equal to Fc. So what is the significance of this? Well, in this actual hypothesis, it says the uniform circular motion of the capsule around the ISS can be accounted for in terms of the gravitational force between the capsule and the ISS. So if they are not equal, then we can say the uniform circular motion of the ISS is not accounted for in terms, or counted by the gravitational force between the capsule, between the capsule and ISS. And so what we can therefore say, the hypothesis would therefore not be correct. So the hypothesis would not be valid. Okay, so obviously the object is still in uniform circular motion, is what they're claiming it is. So if it's a circular path, but the forces don't match up, that means there must have been additional force applied to our capsule here to keep it in a circular motion or uniform circular motion around the space station. So we could also add, and I'll do this in a different color, just to represent, because it's a different type of issue. So in order for uniform circular motion to occur, there needs to be an additional force on our capsule. And that's how you do the problem. So let me just expand this back out. The question was, if the object is to go in uniform circular motion, would the gravitational force be sufficient? We can see that the gravitational force is much smaller than the centripetal force. They are not equal, and therefore we cannot get uniform circular motion. As such, the hypothesis is not valid, or you could say is incorrect. In order for uniform circular motion to happen, then there must be an additional force applied on the capsule. If you found this video useful in breaking down the components of the question, what you need to do and what you need to add, and how you can cross-check you've answered the question correctly, like and subscribe, and I will see you next time.